Okay, somehow I clicked the wrong button. All right, here we are. So let's just take a look at this problem and kind of get it set up. Now, one of the things that we have here is we've got a mixed um, 2 hours, 11 minutes, and 18 seconds. That doesn't give us a decimal of the hours. Okay, um, it's kind of screwy. There's an uncertainty of 21 meters in the distance. Well, that's pretty easy to figure out what that uncertainty is. So you can figure that out, and then calculate the percent uncertainty in the elapsed time. Okay, so and I think we can probably. If it's 2 seconds, you just don't want to look at the 18 seconds because that would give you an error of 11%. And if it's accurate within 2 seconds within all of this, we have to what we have to do is we have to look at what is 18 seconds is what is 18 seconds in an hour, and what decimal is 18 seconds in an hour, and what decimal is 11 minutes in an hour. Okay, and then we'll add those two together and give us the decimal time, and we will know that 18 seconds this and convert the entire. Oh, I know what we can do with 2 seconds. Convert this entire thing. See, I didn't solve this ahead of time. I do this all the time. Convert this entire thing to seconds, and then you got it. Convert the entire thing to seconds, and then take 2 seconds divided by that total conversion, and then that'll be your error in your seconds. Okay, and then how come I can't scroll any further? Oh, I must have to answer the first parts of the questions. Okay, and then the second part of the question becomes when you do the uncertainty for their, because they're going to ask you what was their speed that they're going in kilometers per hour or something like that. You'll have to convert kilometers divided by the total hour time, or get the seconds and convert that to minutes and seconds and all that. And then there's a certainty of distance, and then add the two uncertainties together to get your uncertainty for the thing. Did that make any sense? Didn't make any sense to me. Okay, so let's take a look at it. Let's take a look. All right, so I'm a little perturbed that I can't get what is the in meters. What's the runner's average speed in meters per second? Okay, so we can figure out the total seconds. What is the uncertainty in the average speed? So there we go. So so if we're going to calculate this out in meters, so we'll get this in meters, and we'll get this whole time in seconds. And there we go. And we know that it's plus or minus 2 seconds. So what are we going to have to do? So here's the marathon thing, and then we can move on to chapter 2. So here's the marathon problem. Okay, for on my radar here. Whoops. On my radar here, it's the distance. Let me just get all my 43.502 kilometers, which is equal to 43,502 meters. The time was 2 hours, 11 minutes, and 18 seconds. This is plus or minus 21 meters. I'm writing all the. I'll show you what I've got, and this is plus or minus 2 seconds. All right. So now we've got it. So it's not near as hard a problem as I thought it was going to be. All right. So here we go. So they want what's the error for the meters? What's the percent error in the meters? In the distance? Well, again, you just take, anytime you find the error, you take the error, the delta in meters divided by the total distance. That's how that works. Okay, and then on this one, so that'd be 21 over 43,502. There you go. That gives you your percent error. The same thing here, but you got to convert this whole thing to seconds. Convert time to seconds. Put it all in seconds. And then, of course, what you're going to do when you find the average speed in meters per second, hey, you got meters, convert that whole thing to seconds, you got that, okay? And then to find your error, that's what gets tricky. You gotta add, okay? You gotta add the percent error, the delta for the distance in meters, plus the delta for the seconds, okay? And that'll give you a percent error. And then you've got to convert that to meters per second, okay? You've got to convert that to meters per second because so you've got to convert what is that percentage so that this number is equal to x over the meters per second that you calculated. Okay? And so you multiply times the meters per second. Gives you the final answer that they're looking for. Makes sense? I kind of worked that while I didn't work that out ahead of time. Could you tell that?